right now is I can actually started this stack. I can actually watch this stack right now. You see the stack is up now. I have all the okay, there's some problem here. Sorry. Okay, I think the time is up.
Yeah,
okay, I'm sorry about that. So I'll just quickly kind of wrap it up. So what you should have done is you should have actually started those services. You should have actually this process code has to be should have been called like this. I could actually do the same thing. I mean, I could actually this whole thing is now on a cluster, on a Swarm cluster. I can scale this. I can scale even the process code up and down based on the load, which has to be manually done. But at this scenario, this scaling should do automatically. But that's the definition of serverless computing. So I think you got an idea what it is. I mean, with Docker, I think we are just trying to sort of, this is not POC right now. This is not real way of writing a serverless computing node. People are working on it. I need real scalability. And then somebody said latency is an issue because in the Docker, we only have containers and service. And there's still a latency involved in starting this. So latency is an issue right now. And I just leave with this one slide. This is how people perceive distributed computing application evolution will go forward. So you are currently on the private virtualization. You actually have in microservices and API. There are some workloads which I mentioned will be ideally suited for a serverless computing work. So you would actually create you will actually write all these functions, deploy them on a serverless function as a service FAS provider. You'll execute that, and you have a new term called no-ops, but it's just a cliche actually. Because let me tell you, we call it serverless computing, but there are servers involved. But it's not visible to developers. Developers are transparent to it. I just run it. I don't care where the servers are. I don't provision the servers. I just take the function, execute it, run it, get it back, and that's how my application is composed. Thanks a lot.
Thank you.
So we are talking about the event-driven usability of So do we have any performance considerations? Because, for example, I have an event-driven one where I have messaging based.
Yeah.
Where it can drive it. On what basis? Because if I say that I am going to have 100,000 requests per minute, right? So do we say that actually on those scenarios we trigger 100,000 services and then?
See, with Amazon Lambda, I think I think it's fairly. I think the latency is not an issue there. There are real world use cases like companies like Coca-Cola, baseball manager, baseball team, Thomas Cook. They're all actually writing applications based on the serverless architecture. And most of them, what I know is they're all kind of utilizing the Amazon Lambda infrastructure. They have kind of mapped the whole thing out there it scales. You can do scaling and all that.
Because that scalability, when you have a batch-based processing, but on a real-time data where you are going to get millions of records per second or a second and a minute, do you think that this would be right?
See, it's not applicable for long-running batch files. This has to be small.
Lambda have, I think they have some time limit.
Yeah, 5 minutes from if the function is running more than 5 minutes, it will kill it. The function is supposed to run for only for milliseconds. You only build for the milliseconds. So it's such a huge cost saving if you look from that point. I'm not running my servers continuously. I'm sorry. Thanks, Thomas. Yeah. I'm sorry about the demo, but
That's okay.
Yeah.
Hi everyone. Just want to make sure I'm audible in the back. Okay, cool. So what Thomas did and what the previous guy did with the Windows, just a new way of thought or a new way of thinking of building applications is emerging, right? And people are mostly talking about developers thinking in new ways. It's also for the operations guys to kind of deploy the applications in a new way. Both of them are coming together, and it's probably the fantastic time for the applications to go mainstream. So what I've done here, basically, I was just watching through the 3 presentations, and I noticed that people talk about Docker, serverless architecture, and infrastructure as a big term, but I didn't see anything about storage there, right? So I'm trying to bring storage as a concept to this Docker meetup. The presentation that was supposed to be here was on one new startup that Docker acquired. Is anybody? Can anybody mention the name that?
Infinite.
So there's also one startup in the storage that kind of shut its shop last year.
Blocker.
So why is this happening? There's a Docker as a community is acquiring a new startup, and there's a pioneer in storage, which is Blocker, which kind of had to shut its shop, right? So this talk is not about any demonstration or it's not about code per se, but it's about what are the trends and how the thoughts are changing about how the application should be, or what the infrastructure should be, right? Okay, but I work at CloudByte, and we are also a storage startup. We have started something called as OpenEBS. It's on the lines of Infinite. There are a lot of things that we can compare against each other, but there are also some differentiating factors. It's an open source project. We'll talk more about OpenEBS later if time permits, but mainly I'll focus on the general trends in storage. Okay. How many agree that you're happy with Docker? I know like developers are definitely happy. I kind of saw the show of hands earlier. All the developers are sitting here and all the people who are in the operations are sitting here. It's almost like a 50-50 thing, right? This side of the people are definitely happy. They're always talking about like stateless containers. I don't need to worry about any infrastructure. I kind of saw the term used. I don't care where it is running, right? But does this group agree to that? I can see some people nodding negatively. But one thing that Docker has done is the barrier to start containers is so simple that the growth is phenomenal, right? It just started in 2003, but there are already 5 million software downloads and 650K registered users for Docker. This is what virtualization did in like 15 years. Docker was able to do it like in 2 years, right? So it's tremendous. But really, like let's say developers are building like really great apps with Docker. So I just kind of took this one. So this is like a developer app, right? They're building their apps. They're very happy with it. But to send it into the production, you have to like go place it somewhere. Let's assume this is a Docker hub. It has to kind of get packaged into big containers, and then you just have to put them into the ocean where they have to be long running, or they have to like be alive for a very long time. It's not about like 10 minutes running the job, or, it's not like a big job. When you are running HTTP services, they have to be up and running for a longer time, right? So what's the main pain point for operations guys, right? Any downtime, usually you don't know when it happens, but when it happens, there are like 100 people calling you to fix it. And then for the business, it's like always about money, right? You're basically losing money for every single second that you basically have a downtime. So people talk about like, I don't care about infrastructure, but this is one recent event that happened. This is in Australia where, not that one. So the next year. So the services were running in the Amazon Web Service. At least we know Domino's Pizza, right? But they kind of moved everything from their virtualization, like the private cloud, into Amazon, and then because of some storms that were happening, the entire data center had a downtime. The Amazon data center had a downtime, and for 9 hours the applications were down. And this is the real incident. So I basically have the link for that one from there. I'll share this slide later. Okay. So when you put a lot of stuff on the infrastructure and you assume the infrastructure will work, there can be rough tides and things are going to go down. This is how the developers and the production people think about Docker. Developers are only just thinking of the Docker, and then this is what happens in the production. There are like multiple layers that have to be built. This actually went viral. There was one guy on Twitter who posted this, and this went into the DockerCon and the VMworld. It kind of became a very good slide. I just borrowed this slide from there. So in production, we need high availability, security, disaster recovery, etc., etc. So stateless containers if you think about it for a moment, right, it's an oxymoron. You cannot build any application that is stateless. We're talking about serverless architecture with a lot of green blocks, but there are some red blocks there, which you need to save that data, even if it's a voting app, or like even if it is like your Jenkins stop CI, you need to save that passed or failed somewhere. Right? The state has to be saved. Right? So storage or like the persistent state of that job is important. Right? People are starting to realize that now. So Docker definitely is building the ecosystem where all of these things are coming together. So let's look at this. So again, like we have a swarm that's been introduced now. Just like putting on. Actually, whenever I look at this phase, I don't know how many of you agree. I've actually worked with service providers in production, and then this kind of is mocking at me. The smile of the Docker, it's happy there, but the moment it comes here, it's really mocking at me. Right? So fine, with Swarm, we got the high availability covered. But what about the rest of the things, right? Um, so many of the people here are Linux. I know there was one guy who was trying to compare a lot of things with Windows here. But for me, till Windows becomes free to use, I don't know if I'll go there. See again. So availability is kind of taken care, but also like the security Docker, I actually forked the Docker code and then I kind of tried to hack it. And then the TLS, Nishant was also mentioning, right? It was difficult for him to kind of set it up. It was equally difficult for me to set it up. If people have figured out how to use the security by default, it's amazing. Right? By the way, the CEO of my company is here. We can hire you for our company as well. If you know how to set up the security in content. Okay. So Flocker, this is probably going to be a little bit of history, but if you all, I know like there was one meetup a few days back of how to write a volume driver. So I'm not going to like spend too much time on this and directly jump into like the new trends that are coming in. But generally, like what people are talking about is container can run anywhere. It can die here and go there, but it needs the data to go, right? Flocker kind of pioneered this one where you basically use external storage. Before going there, right? So stateless container, you can do some things like that, but for even for doing a front end like the credentials or like the database, analytics is the main part when we go to the operations, like the logs that the application generates, they have to be stored somewhere. Okay? So storage is definitely coming mainstream. Both Kubernetes and Mesosphere, the popular orchestration tools, have started supporting persistent storage, and it's Infinite acquisition is definitely one of them. So one thing is, the storage vendors, we are also part of that game. Whenever we see a buzzword, we try to latch onto it. We want to like make more money by selling to catching on to some word like that. So many people they started off by using the Flocker model, where you basically connect your old storage, like you take your DMC or NetApp or like any storage that was developed for like 20, 30 years, and you just say like I'm container ready. So what they're really saying is I just create a plugin to you, so where you can connect my storage and start using it. Right? Let's see how this connecting the storage thing itself has evolved. Um, this slide is from the Flocker website. So you basically have some external storage provider that's exposing iSCSI or NFS or any of those kind of things. And you basically use the -v option in the Docker that was introduced to kind of consume that storage. It goes down, you mount it from the other side. It sounds very simple. The storage is already there, you're just using it. But what about the app consistency? This is like all, you're removing the cluster, so it's a graceful shutdown. The data you assume is very consistent. But in production, the stuff happens where data is not consistent. Right? So you need a new way of, some new storages where the data can be consistent for the apps. Right? Docker by default didn't provide. So even though we used that to connect, there was like a control service that was there that was, it was like outside of the regular command line of the Docker, where you have to go and say, take regular snapshots. I basically when I'm mounting the next volume, I go and say like, restore from this and then mount it. How many know about Convoy plugin?
Heard the name but never used it.
So never used it. So this is from Rancher, but both of them came around the same time. But now this guy has shut down, and then Rancher also has stopped development on it from last November. Right? There's a certain reason for that. Okay. So basically, the first version of connecting the storage was like this, where you start with a container runtime, like a Docker or anything, and then you use the plugin model, and you have to go through the control plane to auto provision, or if it is a pre-provisioned, you can directly use those volumes. Right? This one of the main challenges with the operations is like how do you maintain the plugin versions? You're talking about DevOps where you have container images which are like versioned and they don't get changed. They run in developer environment and they run in the production the same way. And now you're introducing these volume plugins, right? And the volume plugins they typically have some versions. And you find a bug in the volume plugin, you have to upgrade it. So though we have solved the problem of apps maintaining some consistency, the plugins are not. Right? Um, Different Docker posts containing different versions of the plugin, it kind of becomes a headache. Anyway, all these storage companies and many more said that we are container ready. storage. Networks also is a huge beast like this, but yeah, we work panel. We're definitely doing some inroads into that. Capacity and data protection are something that people have understood and are taken care of. But you need to have elastic deployment. The software defined, the distributed, scale out architectures. They are going mainstream. We'll just look into that. Somebody asked here about low latency. When you when you're working in a microservices architecture, it's all about connecting from different hosts. How do you make it low latency, right? And then it still has to be easy for the operations people to provision it. And then, of course, we don't want to repeat what happened with Amazon AWS, right? That incidents. You want the infrastructure to be distributed across multiple cloud providers. Google or this one, the chances of them going down are low. So while they scale out, I'm just showing some tick mark here. This is a trend that's been well established, and most of the storage companies have adopted it, and it's mainstream. It's production ready, right? So elastic deployment, where you kind of go and attach nodes to your storage cluster, and you don't think about which phase. Right? It's almost like no single point of failures, and you don't share anything between two nodes. Right? These are the new startups that are working for containers. We used to have like cloud native apps. Now, like that, you basically are talking about cloud native infrastructures. So, in the storage, these are the cloud native storage technologies you can call. CoreOS, this is from the same people who have given the HCD, and the Google is definitely backing it. Infinite, now Docker is backing it. And then we are one of these people, like OpenEBS, we are backed by Longhorn Rancher people, that we're kind of building on top of their technology. And then there's another company called Portworx. I actually didn't get a lot of chance to explore Portworx, but I've gone sufficiently enough on this. So in the next slides, I'll be focusing mostly on these three companies rather than this. Just that I have not gone through that. So elastic deployment has definitely gone mainstream. So the next one is about ease of access, right? How many of you are comfortable iSCSI with iSCSI? How do you mount the storage? You can see some smiles which are not so happy. So what's your favorite way of connecting the storage to the computer? Nobody has ever tried that. Mount points. NFS. It's one way good that we don't have to worry about how it is mounted, right? It has to be that way. Exactly right. So there are definitely some, like Taurus is doing in BD, where the orchestration layer automatically mounts it, so you don't have to worry about whether it has or anything inbuilt into that. Similarly, like Longhorn and OpenEBS are trying the TCMU way, where the devices appear as local block devices. You don't care about how the replication or like the data is flowing to the external storage boxes. This is a trend that's kind of catching up. That's why I put that in orange. Hyperconverged. Nutanix was one of the huge hits last year, going IPO and all that. And that term has become synonymous with how do you get that same concept in the container world. Infinite. This is a diagram from Infinite. They say that this is for production. They still want the operation people to feel safe, but that's how that's going to be, right? Developers are going towards that, and in the near future, even the productions will look like that. Both your containers and the storage will be on the same nodes. And there's a reason for why the nodes can now take on more storage capacity. We'll just look into that in the next screen. So what I'm talking about here is about the storage orchestration. So the trends that I have, I've kind of divided into three. One is about the connecting that we have matured to a certain extent. The second one is about the orchestration of how you are connecting the storage to the Docker host. And the next one is the storage technology itself. All of this have to evolve in a synchronous way to kind of make all of this reality, right? So for example, this is still in the evolving stage because to kind of go here, we need some enhancements or changes to happen in the way the hard disks are delivered or like a flash is delivered. It's still in the making. Okay. So hybrid clouds are definitely here. So earlier hybrid clouds just meant like I have a private cloud and I have one preferred vendor, but it's no longer like that. Even though this kind of shows that I have an in-house orchestrator, and I will be going to different clouds. And if Amazon is going to charge me more, I should be able to move those apps to, let's say, Google or to software. Um, so something called as federated cloud services. It's going to be like a federated infrastructure that's coming up. If you look at the volume drivers of Kubernetes, you can see it connecting to AWS block storage also. So this is a cool one. Um, so the people who build the technology itself, right? They are also programmers. They are also developers. So whatever benefits the enterprise apps are using, that same benefits can also be taken to the product companies as well. How many of you work in product companies here? Um, cool. Um, so the apps are definitely being built by the product, and even the infrastructure products can be built using the container technology. Right? Um, so, for example, like the Longhorn is also one app where the storage services are actually packaged into an image file. They are on Docker Hub. You can kind of say, I want this storage service. You kind of download, install it, and then you're up and running. Right? Taurus is also trying to do that. What we are trying to do is basically make it as seamless as possible to integrate into the orchestration layers. Okay. So these are the enhancements that are happening in the storage technology. So I talked about like hyperconverged, right? For that to really happen, so Intel is kind of hitting the NVMe flash drives. Samsung and Intel, in fact. You basically can put a high capacity flash into your boxes. What used to come as like 8 GB, 16 GB, now you can go into terabytes of flash, and that's very cheap. You start seeing deployments of storage where you may consume a 20 TB of data, which may be actually at like a local disk, hard disk, or it could be in the cloud, but they will be available to you via the flash at the flash speeds. Okay. So there were a few more things that I couldn't like kind of put them here, but there was one definite thing that I liked was Data Hub that was initiated by Flocker. I I hope somebody picks that up now and then kind of takes that forward. It's to be seen. And then cloud federated infrastructures are definitely here. Right? So one thing that I'm seeing is the like the way I said about Microsoft, right? Microsoft also is like having a lot of open source projects now, but all the product companies now have to be open source sooner or later. Right? Infinity code is not yet open source, but I think it's going to be in like 2017 sometime. Because I am working for OpenEBS. So this is like the architecture that's currently working in OpenEBS, where we have something like hosts. These are like your Docker hosts, right? And then just like Swarm, you basically have something called as OpenEBS masters, through which you can launch the Docker containers. We call them as VSMs that expose the storage that can be accessed via the CMU and big data. Right? I don't want to get into the details of this one, but we are definitely looking for like this whole thing is written in Go, so we are looking for contributions from the Go first. Okay, that was my last slide.
EBS is using this for the EMC.
Which storage is from EMC? This is from Rancher, guys. So the Rancher started the core technology of it, and we are taking it forward to kind of deliver it the DevOps way. And then writing the orchestration layer around it. So this should be a clear distinction between the orchestration like Kubernetes, specific orchestration functionality that is required for the storage, and kind of launch the storage containers. So kind of working.
So the idea is to package it along with the orchestration tools to when it's on the Docker image to also store this Docker
Okay, that's spot on. So you basically have these pods, right?
Yeah.
So along with the pods, you should be able to say that, I have this storage pods also that needs to be spawned, right? And then the whole pod should be provisioned on any of your hosts with the hyper conversion in place, right? The storage and the compute and the network. Networks are also like that now, right? They're getting there. So your pod will contain your application as well as your network and the storage. So whole entire thing.
Can we play around right now with this? Is it,
Sure. Actually, what we have done is like it's available. It's in a pre-release format, and sure.
okay, but it is available for us to.
Yeah.
Okay.
The management of the EBS is already is better than the EBS, open EBS.
Correct. So right now it is done by OpenList, but it will be done by the Kubernetes itself. It will be having the connector there itself to do it.
So you're saying right now it's done. How do you?
Yeah, right now it's okay. So for example, sorry, the slide went down. My slide had a front-end container and a back-end containers, right? The back-end containers are the ones that will be running on the actual storage infrastructure or like wherever the actual disks are, right? But the front-end container is the one that connects you to the app. That front-end connector can be launched alongside your pod, right? So we are still working with the Kubernetes to kind of get that working, but laying down the, for example, the storage infrastructure and just playing with the backend containers and front-end containers is available.
So there are examples right now on this slide.
Yes. Yeah. It is not ideal for me.
Thank you. Good, so we are good for the last one, right? So we'll just finish in time. So I'll make it very fast, so I don't have any slides per se. Forget about myself. My name is Nipen Tikhare and I'm running this Docker Meetup group for almost 3 years now. And we provide consulting and training on containers. I work for I'm founder and assistant for Cloud Yoga, and we provide consulting and training around containers. That's currently my focus area from last 1 year when I started this company. Okay, anyway, coming back to the topic right now, what we have to discuss is how we can do a testing with Jenkins and with Docker and all such things, right? So how many of you know Jenkins? Everybody? Not everybody. But I think most of it, you know Jenkins or you use something or the tool at the same time. What is the tool? Is that you do something for testing, right? So you have Python application, do testing of that, right? Whether it's Jenkins, something else, whatever you use, you do testing of that, right? That is something which is very common to everybody. Now, how do you do that? One is that basically you take the application, then you bring a environment where you will test, you have the test cases there, right? That's how we do it. So what we have here is on my screen, everybody is able to see. Should I increase the font more? Good. So we have this blueprint example from which I have got from the Flask website. I'm not going to look at the code, I'm just going to look at the test case. What are the test cases here? So basically, we have a test file here called test_blueprint example.py, which is run some test cases there. And if you use PyTest framework, you can just type py.test and just test it. That's the only thing. You just run tests in some way. If we are trying to how to run test in Python, just run py.test here. So if I run the py.test here, what will happen? Will it run? No. Because I don't have that installed here on my machine. This is my bare machine. I don't have it installed here. So how do I run testing? First of all, I need to get the test package there, which I'm going to test. So what I want to do it, as you might have guessed now, I'm going to create a container in which what I'm saying that mount my current folder, the folder in which I have the blueprint example under the slash code of the container, right? So I'm starting a container from which image? Python 2.7, right? So I want to start a container, and container I'm going to run the test. So I just name the container. Now I'm going to because again if I run here, I will not find my framework here. It's not there. Command not found. Quickly I'm going to install that. I'm going to install two things. One is Flask and one is the PyTest. I've installed these things in my container. Now, if I just run py.test, it is going to test my program. I want to locate here, but the idea is simple. You can run any framework and do a test of that, right? Takes so much time. So I need to go to that, sorry. I have to go to that slash code folder, right? Currently, my current folder is root, where I don't have the code. My code is under slash code folder. Here is my code. Then I'm going to run the py.test program here. And you can see the test is passed. That's the thing I'm going to show. So what I did right now is we have taken a container and we will test. Okay, now think about a use case where you want to test for Python, for Java, for Go, for Python different version, right? So what you will do in that case, you start a container and do a testing of that. And then once the test is over, now I just go and do exit here. And my container has died. That means I still got to my fresh machine now. I did a testing in a fresh machine.